Good morning everyone. So today let us continue the problems based on symmetric and skew-symmetric matrices. So in the last class we have studied about the theorems, right? So we have studied the 8th theorem. So we can recall the statement of that 8th theorem, okay? So prove that any square matrix can be expressed as sum of symmetric and skew-symmetric matrices. Okay, so let us solve some problems based on that theorem. Okay, so here second problem. So in the last class we have solved one problem, so let us continue. Second one, express the matrix matrix 3 5 1 minus 1 as the sum of symmetric and skew-symmetric matrix. Symmetric and skew-symmetric matrices. Okay, so this is very important for 3 marks. See here, we have to express the given matrix as sum of symmetric and skew-symmetric matrices. Okay, so by using theorem number 8, what is the sum of any square matrix can be expressed as the sum of symmetric and skew-symmetric. So therefore the equation is, we know the equation in that theorem, that is A equals matrix A equals 1 by 2 into A plus A transpose plus 1 by 2 into A minus A transpose. So this is the expression to express the given matrix in the sum of symmetric and skew-symmetric matrices. Okay. So here let us take the given matrix as matrix A. Let matrix A equals, matrix A is the given matrix, that is 3, 5, 1 minus 1. Okay. So now let us write the transpose of this matrix. What is the transpose of A? That is A dash, A transpose, which is equal to, definition of transpose means interchanging rows into columns. First row is 3, 5. Let us change to the columns 3, 5. So second row 1 minus 1. Change to the second column 1 minus 1. So this is the transpose of the matrix. Okay. So call the expression as equation 1. So here we clearly know that 1 by 2 into A plus A dash is symmetric and 1 by 2 into A minus A dash is skew-symmetric. Right. So here let us express each expression. So here first find 1 by 2 into A plus A dash, that is 1 by 2, that is symmetric term. Okay, 1 by 2 into A plus A dash, which is equal to 1 by 2, write that as it is 1 by 2. Okay, see here we can clearly see that A plus A dash. So here we have matrix A and here we have A dash, that is transpose. Let us add here itself, addition, right? So let us take the addition of these two matrices now. So since addition means we have to add their corresponding elements, or we can take the substitution here. See here 1 by 2, write that as it is. Matrix A. Matrix A is 3, 5, 1 minus 1. Okay. Sign is plus. A transpose. A transpose is matrix 3, 1, 5 minus 1. Okay. So let us simplify this one. So here 1 by 2 into, so here we can observe in between these two matrices there is a sign, plus means we have to add their corresponding elements. Let us add 3 plus 3, 9, right? No. So 3 plus 3 is 6. We are adding. Don't take multiplication. Almost this term will get wrong because you will take multiplication. Okay. So clearly we have to take the addition. 3 plus 3 is 6. 5 plus 1, 6. 1 plus 5, 6. Minus 1. So plus into minus becomes minus only. Minus 1 minus 1 minus 2. Okay. So now multiply this 1 by 2 inside the matrix for each element. So if we multiply, we get 1 by 2 into 6 is 2 ones are 2 threes are gets cancelled, we get 3. Again 1 by 2 into 6 is 3. Okay. 1 by 2 into 6. Again we get 3. Okay. 1 by 2 into minus 2. 2 gets cancelled. We get minus 1. Okay. So this is symmetric matrices. That is 1 by 2 into A plus A dash. That is the first term from the equation 1. So now let us take the second term of that equation. What is the second term? 1 by 2 into A minus A dash. Okay. So write that 1 by 2 as it is. So let us substitute. What is matrix A? So matrix A is 3, 5, 1, minus 1. So this is matrix A. So next the sign is minus A transpose. A transpose is 3, 1, 5, minus 1. Okay. So in between these two matrices, there is a sign minus, means we have to subtract their corresponding elements. So write that 1 by 2 as it is. 1 by 2 into matrix. So let us take the subtraction. 3 minus 3. 3 minus 3 is 0. 5 minus 1. 5 minus 1, 4. 1 minus 5. 1 minus 5 is minus 4. Minus 1. So here minus into minus becomes plus 1. Okay. Minus 1 plus 1. So minus 1 plus 1 gets cancelled. We get 0. Okay. So now multiply this 1 by 2 inside the matrix for each element. So if we multiply, here we get 1 by 2 into 0 is 0 itself. 1 by 2 into 4. So 2 ones are 2 twos are gets cancelled. We get 2. Okay. So 1 by 2 into minus 4. So 2 ones are 2 twos are gets cancelled. We get minus 2. 1 by 2 into 0 is 0. Okay. So here we have find out two terms of the equation 1. So let us substitute that two values. So this is 1 by 2 into A plus A dash. This is 1 by 2 into A minus A dash. So substitute these two matrices in equation 1. Okay. See here. So therefore equation 1 becomes okay. What is the equation 1? So left side we have A. What does A means? Matrix A is 3, 5, 1, minus 1. Okay. So which is equal to first term is 1 by 2 into A plus A dash. So we have find out that value. 1 by 2 into A plus A dash is, that is matrix 3, 3, 3, minus 1. 3, 3, 3, minus 1. Okay. So this is the first term I have substituted. So next the sign is plus. 1 by 2 into A minus A dash. So this value is also find out. So it is here. Okay. So if we substitute, we get 0, 2, minus 2, 0. See here, we have expressed the given matrix in sum of symmetric and skew symmetric matrices. Okay. We can observe here. So here clearly, if we take the transpose of this one, we get the same thing. That is the definition, right? So if we take the transpose of any matrix, if we get the same matrix, that matrix we call it as a symmetric matrices. Okay. For skew symmetric, so particularly in skew symmetric, what is the principal diagonal elements? It must be always 0. We can observe here. Principal diagonal elements are 0. Okay. So here, if we take the transpose of the matrix, we get minus of that matrix. That is the definition of skew symmetric. Okay. So this is the required expression. So we have expressed the given matrix in sum of symmetric and skew symmetric matrices. Let us move on to the next problem. Similar as previous problem. Okay. Express the matrix. So here given the matrix is 1, 2, 3, 4 as the sum of symmetric and skew symmetric matrices. Okay. We have to express the given matrix in the sum of symmetric and skew symmetric. So let us take the given matrix as matrix A. Let matrix A equals 1, 2, 3, 4. Okay. Then what is the transpose of A? That is A transpose equals interchange rows into columns. We get first column is 1, 2. Second column is 3, 4. Okay. So what is the expression? So the expression is matrix A equals 1 by 2 into A plus A dash plus 1 by 2 into A minus A dash. So here in previous problem we have taken each terms separately. First term I have considered, then I have find out the value of the first term, and next I have considered the second term, and then we have find out the matrix for the second term. Then we have substitute the given expression, that is we have taken the expression as equation 1, we have substituted the two terms in equation 1. Or otherwise we can do in another way is, let us substitute directly here itself. See here, matrix A equals 1 by 2. So this is the another method we can use as similar as same previous problem. So which is very easy, you can use that one. Okay. So here half into, so first term is A plus A transpose. Let us take A plus A transpose. So A is 1, 2, 3, 4. Okay. Plus A transpose. Transpose of a matrix is 1, 3, 2, 4. So this is the first term, that is half into A plus A transpose. Next plus half into, again 1 by 2 into A minus A transpose. Again A is matrix 1, 2, 3, 4 minus A transpose. So transpose of A is 1, 3, 2, 4. So we can directly substitute the matrices in the equation 1 also. Okay. So matrix A equals, let us simplify, 1 by 2 into matrix, here in between these two matrix there is a sign plus. Let us add their corresponding elements. So 1 plus 1 is 2, 2 plus 3, 5, 3 plus 2 is 5, 4 plus 4, 8. Okay. So next is plus 1 by 2 into matrix. So in between these two matrix there is a sign minus. Therefore subtract their corresponding elements. 1 minus 1, 0. 2 minus 3, minus 1. 3 minus 2, 1. 4 minus 4, 0. Okay. So here matrix A equals, multiply this 1 by 2 inside the matrix for each element. Okay. So we get 1 by 2 into 2. 2 gets cancelled. 1. 1 by 2 into 5 is 5 by 2. 1 by 2 into 5. Again 5 by 2. 1 by 2 into 8. 2 1s are, 2 4s are gets cancelled. We get 4. Okay. Plus. So multiply this 1 by 2 inside the matrix. So here also we get 1 by 2 into 0 is 0. 1 by 2 into minus 1, minus 1 by 2. 1 by 2 into 1, 1 by 2. 1 by 2 into 0 is 0. Okay. So lastly, let us substitute what is the matrix A. Matrix A is the given matrix. So therefore, we get 1, 2, 3, 4, which is equal to, so symmetric matrix is 1, 5 by 2, 5 by 2, 4. Okay. Plus skew symmetric matrix is 0, minus 1 by 2, 1 by 2, 0. Is it clear? So this is the required expression, that is the given matrix is expressed as sum of symmetric and skew symmetric matrices. So here only we can verify directly. See here, for symmetric matrices, this is the shortcut, but don't use in the theory. Okay, you can use in a CET. See here, in symmetric matrices, if we take the folding, suppose here, if we take the folding, see here I can take another example. Okay, 1, 3, 3, 4. See here, this is the 2 cross 2 matrices. Suppose if we take the folding like this, okay, in a triangle shape. Suppose it is a square form, okay. So if we fold this edge to this edge, okay, if we take the folding, this 3 comes on this 3, right? Okay. So if we are getting the same elements, then it is a symmetric matrices. Or you can take the transpose. If you take the transpose of this matrix, we get the same one. So therefore it is symmetric matrices. For skew symmetric, the condition is principal diagonal must be always 0. So here, if you take the folding here from this edge to this edge, so if you take the folding, so we get in a triangle shape, this 3 comes on this minus 3. So here in skew symmetric, elements are same, but they are in opposite sign. Here, the elements should be same and in same sign, but in skew symmetric, it is in opposite sign. This is the short way, but don't use in theory. So we have to apply only the definition in the theory. Okay. So this is the required expression. So next question is, express the matrix. So here given 3 cross 3 matrices. In previous 2 problems we have solved in 2 cross 2. So this is a 3 cross 3 matrix as the sum of symmetric and skew symmetric matrices. So here also we have to express the given matrix in sum of symmetric and skew symmetric matrices. Okay. First let us name the given matrix. Let us take the given matrix as matrix A. Okay. So matrix A is 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. Okay. So let us take the transpose of this matrix now. So if we consider the transpose, we get A transpose equals, transpose means interchanging rows into columns. That is 2 minus 2 minus 4. First row is changed to first column. Second row is changed to second column. Minus 1, 3, 4. 1 minus 2 minus 3. So this is the transpose of the matrices. So here we have to express the given matrix in sum of symmetric and skew symmetric. Let us consider the expression. We know that the expression is A equals half into A plus A transpose plus half into A minus A transpose. Okay. So this is the required expression. So call this as an equation 1. Okay. So let us substitute here. Matrix A equals half into, so here half into, first term is A plus A transpose. Here we have matrix A. So matrix A is 2 minus 2 minus 4. Okay. So here 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. This is A plus A transpose. So A transpose is 2 minus 1 1 minus 2 3 minus 2 minus 4 4 minus 3. So this is the first term. So next sign is plus half into A minus A transpose. So matrix A is 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. Okay. Minus. So here sign is minus. A transpose. A transpose is matrix 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. Okay. So now we have to simplify each terms. So matrix A equals 1 by 2 into matrix C. Here we can observe that in between these two matrices there is a sign plus. We have to add their corresponding elements. So here 2 plus 2, 4. Okay. Minus 2 minus 1 in addition. So there is no sign changes in the elements. What the sign the elements get? So we have to take that sign only. Minus 2 minus 1 minus 3. So minus 4 plus 1. What is minus 4 plus 1? it is minus 3. Okay. Minus 1 minus 2 minus 3. 3 plus 3 6. 4 minus 2 2. 1 minus 4 minus 3. Minus 2 plus 4. Minus 2 plus 4 is plus 2. Minus 3 minus 3 minus 6. Okay, so this is A plus A transpose. Next, plus 1 by 2 into, so 1 by 2 into, so A minus A transpose. So here we have to subtract. So let us subtract their corresponding elements. 2 minus 2, 0. So we are subtracting means we have to take carefully. Okay. So see here minus 2, minus into minus, plus 1. Minus 2 plus 1, minus 1. Minus 4 minus 1, minus 5. So minus 4 minus 1 is minus 5. Minus 1, minus into minus, plus 2. So here minus 1 plus 2 is plus 1. 3 minus 3, 0. 4 minus into minus, plus 2. So 4 plus 2 is 6. Okay. 1 minus into minus plus. Okay. 1 plus 4, 5. Minus 2 minus 4, minus 6. Minus 3 minus into minus, plus 3. What is minus 3 plus 3? So that 2 gets cancelled, we get 0. Okay. So here left side we have matrix A. Matrix A means given matrix. So that is matrix 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. Okay. Which is equal to, so here 1 by 2 is outside. Multiply this inside the matrix for each element. So if we multiply, we get 1 by 2 into 4. 2 ones are, 2 twos are gets cancelled, we get 2. 1 by 2 into minus 3. Minus 3 by 2. 1 by 2 into minus 3. Again we get minus 3 by 2. Okay. So let us comes to the second row now. 1 by 2 into minus 3. Minus 3 by 2. 1 by 2 into 6. 2 ones are, 2 threes are. 3s are gets cancelled. Okay. 1 by 2 into 2. 2 gets cancelled. 1. Okay. So 1 by 2 into minus 3. Minus 3 by 2. 1 by 2 into 2. So here also 2 gets cancelled. 1. 1 by 2 into minus 6. 2 ones are, 2 threes are gets cancelled. So therefore minus 3. Okay. So next plus. Here also there is 1 by 2 outside the matrix. Multiply for each elements inside. So here 1 by 2 into 0 is 0. 1 by 2 into minus 1. Minus 1 by 2. 1 by 2 into minus 5. Minus 5 by 2. Okay. So 1 by 2 into 1. 1 by 2. 1 by 2 into 0. 0. 1 by 2 into 6. 2 ones are, 2 threes are. Gets cancelled, we get 3. 1 by 2 into 5. 5 by 2. 1 by 2 into minus 6. Minus 3. 1 by 2 into 0 is 0. So this is the required expression of the sum of symmetric and skew symmetric matrices. Here only we can clearly see that. So ನೋಡಿ ಇಲ್ಲಿ ಫಸ್ಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಗೆ ಹೇಳ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ನೀವು ಆಲ್ರೆಡಿ ಎಲ್ಲ ಕರ್ಚೀಫ್ ಯೂಸ್ ಮಾಡಿರ್ತೀರ ಮನೆಯಲ್ಲಿ, ಹೌದಾ? ಹ್ಯಾಂಡ್ ಕರ್ಚೀಫ್ ಇದೆಯಲ್ಲ, ಸೊ ಅದು ಸ್ಕ್ವೇರ್ ಟೈಪ್ ಅಲ್ಲಿ ಇದೆ. ಅದನ್ನ ಇಲ್ಲಿ ಅಸ್ಯೂಮ್ ಮಾಡ್ತಾ ಹೋಗಿ. ಈಗ ಫಸ್ಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಸೊ ಇದನ್ನ ಕರ್ಚೀಫ್ ಟೈಪ್ ಅಲ್ಲಿ ನಂಬರ್ಸ್ ಅರೇಂಜ್ ಆಗಿದೆ ಅಂತ ತಗೊಳ್ಳೋಣ. ಓಕೆ. ಸೊ ಒಂದು ಎಡ್ಜ್ ಇಂದ ಇನ್ನೊಂದು ಎಡ್ಜ್ಗೆ ಫೋಲ್ಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ, ಈಗ ಈ ಎಡ್ಜ್ ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ ಅನ್ನೋದಾದ್ರೆ, ಸಿಯರ್ ಕ್ಲಿಯರ್ಲಿ ಅಬ್ಸರ್ವ್ ದಟ್ ದಿಸ್ minus 3/2 comes on minus 3/2. ಓಕೆ. ನೋಡಿ minus 3/2 minus 3/2 ಮೇಲೆ ಬರುತ್ತೆ. ಇಲ್ಲಿ minus 3/2 ಬಂದು minus 3/2 ಮೇಲೆ ಬರುತ್ತೆ. 1 ಬಂದು 1 ಮೇಲೆ ಬರುತ್ತೆ. ನೋಡಿ ಸೇಮ್ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆಯಾ ಫೋಲ್ಡಿಂಗ್ ತಗೊಂಡ್ರೆ? Yes. So if we are getting same elements, if when we take the folding, so that matrix is always symmetric matrices. This is the shortcut way. Okay, but don't apply in the theory. Because ಮತ್ತೆ transpose ತಗೊಂಡು ನೋಡಿ, we get the same matrix itself. That is symmetric matrices. So let us comes to the skew symmetric. So skew symmetric ನಲ್ಲಿ ಫಸ್ಟ್ ಕಂಡೀಷನ್ ಬಂದು ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗ್ನಲ್ ಎಲಿಮೆಂಟ್ಸ್ 0 ಇದ್ದೇ ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲೂ ಕೂಡ ಬಂದಿದೆ. ಓಕೆ, ಸೊ ಇಲ್ಲೂ ಸೇಮ್ ಕರ್ಚೀಫ್ ಟೈಪ್ ಅಲ್ಲೇ ಫೋಲ್ಡಿಂಗ್ ತಗೊಂಡ್ರೆ ಹ್ಯಾಂಡ್ ಕರ್ಚೀಫ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ. ಸೊ ಈಗ ಈ ಎಡ್ಜ್ ಇಂದ ಫೋಲ್ಡಿಂಗ್ ತಗೊಳ್ಳೋದಾದ್ರೆ ಟ್ರಯಾಂಗಲ್ ಶೇಪ್ ಗೆ ಫೋಲ್ಡಿಂಗ್ ಬರುತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ. ಸೊ ಇಲ್ಲಿ -5/2 ಬಂದು +5/2 ಮೇಲೆ ಬರುತ್ತೆ. ಸೊ -1/2 +1/2 ಮೇಲೆ ಬರುತ್ತೆ. 3 ಬಂದು -3. When we take the folding, so we get the same elements, but here they are in opposite sign. In symmetric matrices, they are in same sign, same elements, but in skew symmetric, same elements, but in opposite sign. We can observe. ನೋಡಿ ಈಗ ಇಲ್ಲಿ ಫೋಲ್ಡಿಂಗ್ ತಗೊಳ್ಳೋದಾದ್ರೆ ಸೊ ಈ 5/2 ಬಂದು ಈ -5/2 ಬಂದು 5/2 ಮೇಲೆ ಬರುತ್ತೆ. -1/2 +1/2 ಮೇಲೆ 3 ಬಂದು -3. When we take the folding. Okay, so clearly this is skew symmetric. Therefore, we have expressed the given matrix in sum of symmetric and skew symmetric matrices. This is very important for 3 marks.